Alright, we have already learned what a central angle is. So this is review, but it's always good to see it twice. See the box where it says central angle? Draw yourself a picture of a central angle. Where is the vertex of a central angle? Where? Location? Center. So the vertex of a central angle is at the center. We also learned something really important, that the measure of the angle is, what's the symbol? Equal to the measure of the arc that it opens up to. For example, if this angle is a 41-degree angle, then arc AC has a measure of 41 degrees as well. So that's really important with a central angle. Its measure is equal to the measure of its arc. Arc's 41, angle's 41. Angle's 29, arc's 29. Why? The measure of the angle equals the measure of the arc. Okay. Okay, let's jump down to that example. First thing you would do on an example like this, on a test question like this, is label your picture. It's right underneath. This is the first thing you would do. Arc CD is 3x minus 5. BC is 2x. AE is x plus 3. CE and AD are diameters. That means they're splitting the circle up into semicircles. And now we need to solve. What we're not going to do is add those up to equal 360. Why can't we do that? Why can't I add those three expressions up to equal 360? Because we're missing, we're missing BA. We don't know BA. And we're missing DE. You can't add it up to 360 when there's holes. So what could we do? Take what? By 180. So you're saying that these three equal 180?
No. X plus 3 and 3x minus 5 are congruent.
Are you guys looking at this? Do you agree that 3x minus 5 is this angle, right? We just learned the angle equals the arc.
The vertical.
Then we've got a pair of vertical angles. We learned a long time ago that vertical angles are congruent. So if this equals this and this equals this, then this equals this. Therefore, we can set 3x minus 5 equal to x plus 3. What are we not going to use? 2x. You don't always have to use everything you're given. You don't always have to use everything you're given. All right, let's do it. You're going to have to do this a lot next year. Solve for x. 3x minus 5 equals x plus 3. Dimitri and Julius, what are you doing? Sleeping. Come on, solve.
I know, this is
the opposite of minus 5. Add 5 to both sides.
4.
3x equals x plus 8. Subtract x. We want to move him over with his buddy. The opposite of positive x is negative x. We haven't done this in a while. 3 minus 1. Yep. 2x equals 8. 8 divided by 2. All right. Okay. X is 4. All right, the measure of angle COD. Kendall, what does angle COD, what arc does it open up to? Name the arc. CD. So we can take 4 and we can Glade commercial it. Thank you, Torin. 3 times 4 is 12. 12 minus 5 is? That's weird. But we're going to roll with it. That's a 7-degree angle. We plugged it in. Yeah. It's a 7-degree angle. Measure of arc CA. Oh, no. We don't know that arc. We need to find the measure of arc CA.
Diameter.
Okay. Let's find arc CB. Brett, what's the measure of arc CB?
8.
What?
8.
4 times 2, 8. You just plug next in.
8 plus 7 minus 1.
So this is 8, and this is 7, and this is a diameter. This is a weird problem. All right.
So it's 8 plus 7.
180 minus 8 minus 7. That's what we're doing. Where did what?
But you,
What's that?
We plugged it in, 4. 2 times 4.
165?
There you go.
wait,
That's a really
isn't
good
it
number.
just talking about CA?
Oh, yeah.
It's only talking about
So we only need you 180 minus
first you would
7.
find BA and then you
What? I'm
add
going too
CB
slow? Is that what I'm doing?
No,
and
you were like
BA together.
173. Because he was talking.
Because people, yeah, I didn't want to, and it was wrong anyway, so. Are you making fun of my voice right
No. He makes
now? 173. The reason is because we needed this whole arc. So we actually didn't need to find 8. We just need to do 180 minus 7. Is everyone okay with 180 minus 7? The picture got a little ugly. Okay. We're going to move on to inscribed angles. Write it down. Write this down. An angle whose vertex lies on the circle. Not on the center of the circle, but on the circle. So the angle I drew, angle ABC, is an inscribed angle because B is on the circle. Now, I'm going to use this word a lot. Intercepted arc. And I'm going to want you to know what I mean. So let me tell you right now what I mean when I say intercepted arc. Pretend that that angle is Pac-Man or whatever you want, and it's chomping down. If that angle chomps down, I'm asking what arc would it eat? What arc would it close in on? So when I say that AC is the intercepted arc, that's what I mean. The arc where if the angle were to close, that's the arc it would close in on. Okay, because that's really important. Now we need to figure out how much this angle is. Because we know that a central angle equals its arc. Remember? 40, 40. But what's the measure of this angle? Can't also be 40. Do you think this angle is more or less than the central angle? So what helps me figure this out is thinking of a bow and arrow. So before you pull that string back, is this a large angle or a small angle?
Large.
Very large. It's almost 180. It's a very large angle, very obtuse. But as you pull it back more and more and more, what happens to that angle? That angle is getting smaller, smaller, smaller. So if an inscribed angle is farther away than a central angle, is it smaller or larger?
Smaller.
Definitely smaller. So let's see how much smaller it is. The green one is my inscribed angle, and the blue one is my central angle. How many of these, this is the inscribed one, how many of these do you think fit into my central angle?
2.
2? 3? 2.5? 1? 4? Okay, let's try. 6. Oh my gosh. So there's 1.
2.
What? And 2.
Yeah.
2 angles. So what does that mean? If this angle is 40, what's this angle? 20. Don't say 80. 20. And what's the measure of this arc? The same as the central angle. So there's going to be double of one number, and then only one of that smaller number. Okay? All right. Write it down. I don't know. Is there a place to write it down?
I don't know.
Just write under that box. You don't write all of this again. Don't write this. All I would write is this. The angle is, excuse me, the angle is half the arc. I can't help it.
Make a
At least I'm not at home. At least I'm sick and I'm teaching you guys, okay? I'm doing my best.
hard work.
Now you're going to make me cry.
It's okay.
Yes. Julius puts his head down for all of class, but when it's time to make fun of the teacher, he's like, oh, I'm awake. Look at me. I can make fun of the teacher.
It's okay, he has glasses.
Low blow, Julius. Low blow.
He's a
Heartless.
Alright, let's try the next example. Ready? You didn't have the information on your paper because I didn't want you to work. Oh, no, you did.
No, you
I
didn't.
didn't want you to work too far ahead, but you had it there. Angle ADC is 152. Oh,
There you go, Kendall.
it's not your turn. Melanie, what's the measure of arc AC? Melanie. What's the measure of arc AC? Yep, 152. A central angle is equal to the measure of its intercepted arc. Matt, what's the measure of angle ABC? 152 divided by 2. 76. It's half the arc. Half the arc. Uh-oh. Omar, what's the measure of arc ABC? Notice, these are asking almost the same thing, but you have to look at the symbols. That's an angle, and that's an arc. It's a big difference. Arc ABC. 360 minus 152? Yep. Very good. Are we okay with 360 minus 152? The major arc. It's a breeze. I knew y'all would like circles. I love it. Okay, next one. Don't ever do anything until you label your picture. Don't even try to answer questions until you fully labeled your picture. ACD is 62. Arc CD, you have to look at the symbols. Arc CD is 58. And arc BC is 47. I'm sorry, what? Because I didn't want you to work ahead. It's right, this is labeled. It's right here. Oh, the letters. Yep, yep, yep.
Thank God he's lower.
I mean, if you could just do 85 with the next breeze.
This one gets a little bit trickier.
Oh, am I supposed to be doing it?
Everyone's supposed to be doing it. Yeah. You can do it. I'm not going to solve anything. I just want to make an observation. I want you to look at that red angle. And I want you to also look at the teal angle. And I want you to notice what arc they are intercepting. Okay, green. What arc is the red angle intercepting? What arc? Torin. What arc? What arc is the red angle intercepting? AD. Yes. Julius, what arc is the green angle intercepting?
The same one.
Name it.
Same one as the same.
I didn't even hear it.
What arc is this angle intercepting? I said you need to know what the word intercepting means.
What is it eating?
If that were a Pac-Man, what arc would it gobble down?
Jesus.
AD. Oh, I thought you were saying add. I thought you were saying the answer. AD. Now we're so far away from your answer, it's not doing what I thought it was going to do. This one is intercepting AD. This one is intercepting AD. Both of those angles are intercepting the same arc. So both of the times you're going to take the arc and you're going to divide by 2. If you take the same number and you divide by 2, both times, you're going to get the same angle. Both times. So we'll go the long way, but in the future you don't need to do it the long way. What's 62 doubled? 124. That's the measure of that arc. Now if you want to find the measure of this angle, you take the arc and divide by 2. But wait, we just doubled it. So if we divide by 2, we're going to be right back where we started. So what's the final answer?
62.
What I'm trying to get across is that if two angles eat the same arc, they are the same measure. Two inscribed angles eat the same arc, they're the same measure. 62. John, what is the measure of arc ADC? 182. Yep. Major arc. Just barely. That's just barely a major arc, only by 2 degrees. The toughest problem of the day is number 6. When you have it, let me know. What is the measure of this arc right here? You should have found that. 131. This angle does not match this arc. That angle is half the arc. That's an odd number. When you divide that by 2, you're going to get a decimal. Oh, and she put 62?
65.5.
Okay. Where did we get 131? These numbers minus 360. Okay. No, it's not it. Right, this next theorem. We've got 3 theorems. 1, 2, 3 theorems.
I had it.
Oh my God.
Oh my God.
Guys, you need to write this theorem down. The opposite angles in a quadrilateral that is inscribed in a circle are supplementary. The opposite angles.
No, I mean,
Dimitri, shh. The opposite angles in an inscribed quadrilateral are supplementary. We are not used to this. We are used to opposite angles being congruent. In a parallelogram, opposite angles were congruent, not supplementary. So this is different, and I need y'all to make sure you understand. In parallelograms, opposite angles were congruent, but that is not a parallelogram. That's just an irregular quadrilateral. So, if this angle is 80, what's this angle? 100. If this angle is 70, what's this angle? 11. Can we move on to the next little box?
No.
Well, we are. Next little box. An angle inscribed in a semicircle, remember semicircle means 180, is a right angle. This one, we actually don't even need this theorem because we can treat this like an inscribed angle. How do you find an inscribed angle? You half the arc. Well, if the arc's 180, what's 180 divided by 2?
90.
Right angle, 90 degrees. So you don't technically need this theorem, but if you do know the theorem, it'll make some of the problems a little bit quicker. You won't have to do 180 divided by 2 every time. An angle inscribed in a semicircle is a right angle. Another way to write that is an angle that opens up to the diameter is a right angle. Any angle that opens up to the diameter is a right angle. Because 180 divided by 2 is always 90. Last box?
Yeah.
This one, we also really don't need this theorem either, but let's write it down anyways. This angle, angle ABC, is not an inscribed angle, but we treat it, God bless you, we treat it just like it's an inscribed angle. So all this is saying is that even though one of his rays are outside the circle, you still get to just take the arc and divide it by 2.
Why are you judging that line? Stop judging me.
So if this arc is 200, then that angle would be 400 isn't even an angle measure in this class.
Good job, Kendall.
Thank you.
You're welcome.
The angle is half the arc. We're going to treat it just like an inscribed angle. Pretend like it's an inscribed angle in disguise. It dressed up like an inscribed angle, so it gets the same rules as an inscribed angle.
Y'all know.
The reason we're treating it like an inscribed angle is because where is its vertex? Where? Where's the vertex of that angle? On the circle. Well, an inscribed angle's vertex is on the circle. So that's why we treat it just like one. Arc is 200, angle's 100.
Yes. I'm going to do something.
Ready? Okay. O is the center of the circle. AC is a diameter. Find the following measurements.
I'm a puma.
Bless you. Everybody has the sneezes today.
Y'all good.
That's a diameter. Yeah.
Y'all good.
Semicircles are always one.
Y'all good. I need to go in here. Y'all good.
I
No.
just-
I do what I want. You know what?
Hey, are y'all done with this problem? Why are you just sitting there? Why are your hands behind your head? Why are you not writing things?
Not cool and boring.
It has no numbers. What?
Not cool and boring.
It has lots of numbers. Here's a number. 180. Here's a number. 90. Here's a number. 45. Here's a number. 45. There's numbers all over that picture.
Nice.
Hi. Wait, not here. Okay.
Bye, senora.
So, measure of angle BAC. Already marked it. 45. Measure of arc ABC.
What's AC?
Is yours different?
Yeah.
Okay, well either way, whether it's arc ABC or whether it's arc AC, it's the same answer. 180.
It's an RB.
And then arc BC.
90.
To find the measure of an arc, you take the inscribed angle. Oh, do I double it or half it?
Double.
Double it.
90.
Almost done. We have to practice all of our theorems. BAD angle bad is 58. And arc BC is 48. And arc AB is 110. Dun dun dun.
I don't like this one much.
But we have a theorem about it. Because if a quadrilateral is in a circle, opposite angles are supplementary.
I'd be good at it. I can do this good.
Before we start answering these, let's just find as many things as we can find about this picture. Opposite angles are supplementary, so I want everyone to find the measure of angle C. Go. Find it. 180 minus 50.
Two.
AB, it says it's 110, not 80.
Thank you. Good job. Good catch. Someone's watching. 110.
I mean, it's so good. Place.
180 minus 58 is 122. What's the measure of angle D? An inscribed angle is half the arc. So Omar already said the answer. What is it?
65.
Very good, Omar. 55. Take the arc and divide by 2.
115.
Find 180 minus 55.
Which one?
Look, we're finding everything. Everything we need. All right. Measure of arc bad. Well, to find the measure of arc bad, we would want to find an angle that opens up to that. So here's the arc. We need to find an angle that's eating it. Oh, I found one. If that angle is 122, how do I find his arc? Double it. 122 doubled. 2, 4, 4. Wouldn't what? B opens up to arc ADC. You gotta follow it with your fingers. It's hard in this picture. Alright, arc CD. Uh-oh. We don't have any angles that open up to arc CD. So we're gonna have to add 244 plus 48 and subtract from 360. What? Okay, good. Good job, guys. Last one, angle CDA. We've totally already found it. CDA. Angle D, 55. Thanks to Omar. All right. Last problem. Measure of arc AB is 120. Alea, what's the measure of arc ADB? Go ahead and find it. $360 minus 120. What? 360 minus 120. 240. Last thing we're going to do today, Catherine, what is the measure of angle ABC, this angle right here? Take the arc and divide by 2. It's not a central angle. We're back where we started again. Okay, that was a coincidence. 120.